All the properties of integer exponents apply to rational exponents. Take note, key concept, properties of rational exponents. Let m and n represent rational numbers. Assume that no denominator equals 0. We'll see properties on the left and some examples on the right. Starting with a to the m power times a to the nth power equals a to the m plus n power. For example, 8 to the 1/3 power times 8 to the 2/3 power equals 8 to the 1/3 plus 2/3 power, and that's 8 to the first power, or simply 8. Next, a to the m power raised to the nth power equals a to the m times n power. For example, 5 to the 1/2 power to the 4th power is 5 to the 1/2 times 4 power. That's 5 squared, or 25. Next, a times b raised to the m power equals a to the m power times b to the m power. For example, 4 times 5 raised to the 1/2 power equals 4 to the 1/2 times 5 to the 1/2, and that equals 2 times 5 to the 1/2 power. Moving to the right, a to the negative m power equals 1 over a to the positive m power. For example, 9 to the negative 1/2 equals 1 over 9 to the positive 1/2, and that's equivalent to 1/3. Next, a to the m over a to the n equals a to the m minus n power. For example, 7 to the 3/2 power over 7 to the 1/2 power equals 7 to the 3/2 minus 1/2 power, and that's 7 to the first power, or simply 7. Finally, a over b raised to the m power equals a to the m power over b to the m power. For example, 5 over 27 raised to the 1/3 power equals 5 to the 1/3 power over 27 to the 1/3 power, and that's equivalent to 5 to the 1/3 power over 3. Recall from lesson 6.2 that you simplified products or quotients involving radical expressions only when they had the same index. However, you can combine radical expressions with different indexes if you convert them to expressions with rational exponents. Simplifying radical expressions. So take note, in the case where we have the mth root of a times the nth root of a, if we attempt to simplify by multiplying radical expressions, we find we cannot multiply the expressions because the indexes are different. On the other hand, if we attempt to simplify using rational exponents, in step 1, we rewrite each radical expression using rational exponents. So the mth root of a becomes a raised to the 1 over m power, and the nth root of a becomes a raised to the 1 over n power. And in step 2, we use the properties of rational exponents to simplify the expression. A to the 1 over m times a to the 1 over n equals a to the 1 over m plus 1 over n. And a simplification is possible. Problem 4. Combining radical expressions. What is the 4th root of x cubed over the 8th root of x squared in simplest form? Consider what you may think on the left and what you might write on the right as you work through the problem. First think, the radicands are different, but both are powers of the same variable. Write the expressions using exponents. And then write that the 4th root of x cubed over the 8th root of x cubed is equivalent to x to the 3/4 power over x to the 2/8 power. Then think, use the distributive property for exponents and subtract the exponents. So this becomes x to the 3/4 power, the exponent from the numerator, minus 2/8, the exponent from the denominator. And that's x to the 3/4 minus 1/4 power. Finally think simplify and write in either exponential or radical form. So x to the 3/4 minus 1/4, well, that's x to the 1/2 power, which is equivalent to the square root of x. Your turn, part A. What is the square root of 3 times the 4th root of 3 in simplest form? Part B. What is the square root of x cubed over the cube root of x squared in simplest form? Part C. What's the square root of 7 times the cube root of 7 in simplest form?